morning, everyone. Our group is going to discuss about the IP design of the digital shower experience. And first of all, I'm going to explain about the customer benefit generated by digital shower experience. Please look at these pictures. This slide shows some of example of the customer benefits. In fact, digital shower has a lot of the benefit to the customer compared to the traditional shower. For example, digital shower includes individual sounds, lighting, and flavor for the best experience based on the customer's expectation, the mood, and preference. By doing so, digital shower could provide well-being experience and life to the customer. And digital shower could improve the customer's health condition, not only a physical but also the mental condition. I mean, digital shower could provide beneficial for the user health as well. In addition, digital shower can also be the customized to the personal preference of the customers. Therefore, customer can relax and use very easily and escape from the busy day in short time without spending a lot of time. It is very good for the health, customer's health. And as I explained so far, digital shower could improve customers' everyday life with the natural elements such as water, sounds, and lighting, something like that, in order to enrich and estimulate their customers' life.
So we learned a lot about the benefits the customer will experience when using our digital shower experience. But our question is, we want to build up an IP and exclusivity on these benefits, and so to keep out our competition to offer the same or equal products with these benefits. We want to exclusify them. So this is the goal, and we have to do some steps to come to see what we should exclusify for our company. And one way to do that is to just set up a virtual shower experience where we walk through and where we derive the impact from these several steps, process steps, on the user benefits. We can adjust them there and see which process steps influence which benefits. And this is the process scenario. We wake up in the morning and we communicate that we want to shower. So shower must be prepared, and we can do that via iPhone or wrist gadget. And these gadget gives us a proposal for a suitable shower scenario, which may be reliant to biometric data too, which we get from the gadget, and we select them. Blue boxes are technical, machine-done things, and the gray boxes are what we need to do. So we also get a hint on the possibilities of IP here, because blue boxes are also, they are automated, they are somehow technical. We select the shower scenario, and if we like that, we can adapt it and select it, settings, make specific settings to adapt it to our mood. We transmit, of course, this showering scenario to the devices where we're in the wireless network business, so to get them working. and the system itself prepares the bathroom. It needs some startup time to, for instance, for getting the heating right, or to introducing flavor or something, and then to communicate readiness status. Then we can go showering. So, and then we perform the sequence of the showering scenario, which is selected from these ones, proposals, and we also, and this is quite important, we document the results, so we can also see on our wristwatch what we feel like after the shower experience. So to optimize the whole process and to maybe give another setting here, which is adjusted in time, and we don't have to select it anymore. So this is the cognitive walkthrough, which we need to assess in view of impact to the user benefits.
Okay, so thanks, Michal. So after we've identified a usage process for our customer, it's important to understand the most important process steps for them. So we have here a useful tool for doing this. Let's see how we construct this. So as Michael mentioned, we have the process steps at the top in the previous usage process. Communicate intention to shower, make proposals for suitable showering scenario, and so forth. Then we have the customer user benefits on the other axis. We take this information from the surveys and so forth, the interactions with potential customers and so on, discussed by our colleagues previously. So we changing everyday activity into a well-being process, holistic experience involving all senses, high compatibility, and of course they have a sort of relative score for the decision-making process of the customer. And again, this comes from the previous interactions that my colleagues discussed. With this, we can go through and we can fill out the matrix, and it's quite interesting. You can see there are some process steps that are extremely important, of course. We have a score of 12, 12, 11, and so forth, and others that are a bit less important. Yeah, and from this we can perhaps construct a decent strategic filing plan and so forth.
Let's talk technology, my dear ladies and gentlemen. In fact, let's keep in eye one of the most important steps in that process for the customer benefit, and look what are technological, let's say, components which are needed physically or digitally that that thing happen. So you need, of course, some input devices, for example, human-machine interfaces, external control devices, external data sources, and so on. You might need some other technological aspects in order to give these impressions, as for example, the whole lighting, fragrance release, sound bugs, air exhaust, exactly. And then, of course, you need a lot of data to be processed and bring you the let's say, wished result. So this whole thing might define technically what are the points which are needed, and then let's go to the next step, which is to find a way to put them in a manner that we can actually see the structure which is needed for the whole thing. So as we see here, that was just the components. No, the point is actually where shall these components be related to, so that at the end we get the output which is in fact needed, for example, individualized showering experience. So you need some sources which convert the technical aspects in order to achieve the output. In order to do that, you need some basic conditions, some basic knowledge which comes from the outside as a sort of cloud all over that. So in the source part we find, for example, the HMI, human machine interfaces, external control devices, as for example your smartphone and anything else, recipe databases, external data sources, as for example the temperature outside and something like that. Then you have actually to convert that to a control system, lighting, movie screen, bathroom fittings, and so on and so forth, which make it let's say readable or livable for the people or for the person who is going to have the shower, and that results hopefully into the individualized showering experience and the health supporting showering, and then it releases some data for us, data on showering habits, which of course we take back as a sort of feedback in order to remove on with a sort of continuous improvement. Then in order to do that, of course you rely on a set of data which is needed, which shall be there in data model, simulation model, data model for health and fitness, and user preference structure, which together with a result in that showering experience.
Okay, so starting from this system overview, it would now be the task of IP design to design some IP that in a meaningful way connects all those elements into IP. We have decided to show this approach by contrast. So my job will be to first show a connection of several elements of this slide the traditional way, and traditional here means in a 2011 patent application by one of our competitors. I don't want to bore you with the details. This patent is basically about a control system and a method for controlling the water release in a shower through several releases. So what we will find in this patent is the control system and the water release, and this we have put into this slide, which shows that in the patent there's a claim which demonstrates the use of an HMI which is put in the shower cabin to select a recipe or sort of a pre-programmed sequence of temperatures, for example, which is then fed into or used by the control to control the water release in accordance with the pre-programmed and selected program, which then creates one of the outputs that we have envisaged in our project, the individualized showering experience. That can, in some advanced methods also disclosed in the patent application or in the patent, combined with a data model, which can be seen or which can be considered a showering recipe, which then can be used and activated using the HMI.
So let's come to the last slide. In the end, we have to protect the customer benefits, and the basis for this is in this case this display of different functional elements we have, and this is our potential invention environment. And what are we gaining for, or what do we have as a basis? As a basis, we have this automated generation and execution of individual shower scenarios adapted to the human being showering. And what is different and in contrast to the past, we have several elements which are connected and based on digital modules, which we can see here, which have this gray color. And what we can now do is using these elements which we somehow configured here. We can combine them and can display and show the connectional functions in between these different modules and how they interact. And this whole concept will lead in this user experience, this shower experience, which we want to protect. So let's take this as an example. There might be different examples, and there will be different examples which we can use as a basis for different independent claims, where we can also derive from dependent claims, different applications. And this is now only one of the examples for generating such a combination which is worth to file a patent. So where do we come from? We come from an external data source which is connected by providing the function of information on actual situations, and we have this situation that we have a simulation module that is connected functionally with a data model, and the algorithms which are implemented in the simulation model will lead to user preference structure, which will feed the control with information about our shower, how the shower has to function, and how the shower will in the end lead here to a health supporting showering experience. And there are different further connections and functions between the control elements and the modules possible, which can be basis on the basis for inventions. Okay, thank you for listening, and have a great day.